13.1 vector valued functions. This is just a general introduction. We're going to do some calculus in the second section. We're introducing this so that later on, at the end of the course, when we cover line integrals, this general introduction will serve you well. There's a lot more to this chapter than we'll cover, but if you take courses in dynamics in an engineering science curriculum, sometimes you run into more of this in a class like that. We're going to start with this vector function 2ti plus 3tj. This is a vector valued function because we plug a time value possibly in and we get a vector out. So the values are vectors. The parameter t could be time, for instance. Well, this is nothing more than x equals 2t and y equals 3t. It's a parametric curve. X and y are both related to time. Both are linear functions. That would give us a straight trajectory. And we could find out what their trajectory is. You could solve for t, divide by 2. T is x over 2. Substitute here. You got y equals 3 times x over 2, or 3 halves x. That's a straight line through the origin with slope 3 halves, quite simply put. Here's a very simple exercise. We're going to sketch this vector valued function. We should expect that straight line. We're going to sketch r of 0, r of 1, and r of 2. Well, first of all, r of 0 is 2 times 0i plus 3 times 0j, which ends up just being 0i plus 0j. Well, that's just a point. R of 1, substitute. 2 times 1i plus 3 times 1j. That's 2i plus 3j. These are called position vectors. They start at the origin. We have to go over 2, up 3. Over 2, up 3. Right here. So there's our first position vector. And we can find r of 2. Of course, that's going to be 4i plus 6j. We're a little bit off the chart here. We're actually somewhere up here. And there's our second position vector. You can sketch the trajectory. The line keeps on going this way. It goes backward. If you were to plug in negative time values, it would go back. That's a little bit crooked. It's going to go back this way. These position vectors also give us an orientation of the curve, by the way. It tells us we keep on going to the right. That's t equals 0. Sometimes we can be a little more descriptive by putting time values in. So that's about all there is here. You should be comfortable in going back and forth. If we're given a parametric curve, very easy to put it in vector form. Very simple. A very simple exercise. If you're thinking hard, you probably missed the point. We'll be back shortly for 13.6. We'll apply some calculus to this.